My name's Marc Sugiyama. I'm a senior architect at Erlang Solutions. And I'm going to talk about how we can design our applications in such a way that they're more easily composed into nodes, so that you can decide sort of at the last stage when you're building the release which applications are included in a node. So to do that, I'm just going to start with a quick review of the sort of the building blocks that the OTP release management system gives us to do this. I'll talk a little bit about what I mean by a distributed application and the challenges there to provide some of the motivation for why I started thinking about this. Then how the applications are designed to be able to compose and to be composable into nodes, and then just a couple of examples that we did that were for the project I was working on last year for a company called Infoblox. It was an open source project called IvanOS, where we started coming up with this idea to make it a little bit easier for us to do our proof of concept work. So just to start with some background information about the OTP releases, we'll sort of start from the bottom up, all the bits and pieces. So as you know, you organize your functions into modules, right, in Erlang, and that processes are going to use code that's in one or more of those modules in the application. An OTP application, and an application, unfortunately, is a very overloaded term. So when I'm talking about, in the slides and when I say an OTP application, I'm referring to the concept of an application that coming out of the OTP framework, right? So that's which they define as a collection of modules and processes. So it's this entity that usually has one source tree, right, and has a .app file. Right, that's what an OTP application is. Yeah. So that application is going to provide some sort of service for the release or the system as a whole. Some people have started thinking of the microservice as this new term that's floating around, and some people say, well, maybe these applications are kind of like little microservices, but they provide some service through a public API. And I'm going to use the API term fairly loosely. It's not just, I don't mean just in terms of Erlang functions that can be called, but also things like messages that come in and out, or maybe a network protocol. It opens a network connection and is expecting requests to come in over a network. There are applications that have no processes at all, and those are just libraries, and that's perfectly valid too. But in here, so we have an OTP application. So usually what defines that is that it has some top-level supervisor that starts all of the worker processes, and then the application also knows about all of the code that's inside of it. And finally, the application has a list of other applications that it's dependent on, right? So all applications depend on standard lib and kernel, but other applications, say, might depend on Mnesia or Logger or what have you, right? So there's this dependency tree that gets built. The applications themselves, we bundle into a release. I call that an OTP release in the slides, to try to make it a little bit clearer, that not like a release of the whole system. And a release is essentially what we mean by an Erlang node, right? So you bundle all the software into a release. That's the thing that you then launch that's running the virtual machine, has all your code in it. Releases are really cool because they are completely self-contained. Once you build the release, you can pick up the whole directory, put it somewhere else, it just runs. And when you configure the release, what you tell the release manager is that you tell it the list of applications that you want to be included in that release. And the release manager then looks at the dependencies first and makes sure that all the dependencies are available, right? So so they're either system applications, so that it already has in its release, its tree, or they are other applications that you've provided, right? It makes that dependency check, then it makes sure that it figures out which one needs to be started first, so that they're all started in the correct sequence. So when your application runs, you know that everything that you're dependent on is already running, right? Now, sort of outside the context of the OTP and the Erlang is the idea of is the repository, right? So this is where we've put all of our source code, right? And it's where we've put all of our configuration for the release and the applications. And what it seems to be happening, what seems to happen a lot is when we build our projects is that we blend together the sort of the OTP application and the release that we need in order to actually use it, right? So for example, if you're building maybe like a caching service, right? You'll have your source directory, which has got all of the code in it that's implementing your cache. It might list some dependencies that you're relying on, like network libraries or client libraries for Redis or what have you. But then you'll also have a release directory, or at least configure the release in that same repository for creating the node that will run that application, right? So the downside of this is that, so the upside of this is that you've got this one thing that's got your code and you've got the way to run it, and you can just in one place build, and you've got your release that you can pick up and deploy. The downside is you've now got this code, say, implementing your cache, say, that is kind of trapped in that one node, right? In other words, you can't easily sort of pick up that code and use it as a library in some other project, right? Because of the nature of the way that the rebar dependencies work and the way that it's been organized into the repository. So that's what this talk is basically about, is about how to do this separation. But just sort of looking back at what the complete hierarchy is, what we've got is the .beam files, or basically the source code, bundled into applications. The applications are then organized into a release. And some of the applications might be part of the same repository, or they might be dependent applications, so they're being drawn in as dependencies from other repositories. Again, like something like Logger, right? Something that's shared. And then the sort of the gray area, the grayed out area on the top and the left is meant to say that those are the bits that are in a particular repository, one repository. And then we take what's in that repository, we build the release so that we can get a node that we can run, right? Is that pretty clear? Yeah, okay. All right, so we've built our application, we've got our nodes running, and then it's actually one part of a larger distributed application, right? Where what I mean by a distributed application, that you have maybe in this diagram, each of the boxes is meant to be a node. Maybe you've got some connection handlers, you've got something that manages state, there's a cache, there's other services that are running, and they're all running in different nodes, right? In order to, say, maybe have better load balancing, or to spread the load out, or to have some redundancy in case of failure, right? So so we could see how you would have, say, a separate repo for each of these different pieces. Okay, so this is good, but my experience has been sort of doing testing and debugging in an environment like that. It can be pretty challenging, right? Because in order to do anything, you have to have all the pieces running, right? And then if you, say, have a request that comes, you're trying to debug what happens. Say one kind of request comes in, you have to then sort of trace that request around the network. Maybe turn on tracing in the tracing or some sort of debugging in all of the nodes, and then look around and see where the messages are, what's actually happening in each of the pieces and try to correlate them all together. And that can be pretty challenging. So what would be really nice is if we could be able to sort of run everything all together, right? Even though that when we deploy it, they'll be separate, we can run them together, but we'll get to that. The other thing is that, again, because of the way the repositories are structured, it makes it a little bit more difficult to share the code, right? You can't easily take a piece, wrong way. Take a piece out of the connection code and maybe use it in the sessions or vice versa, right? You can't easily sort of like take a chunk out and move it from one place to the other because you can't use one as a dependency of the other because they're releases. They're not applications. They're not simply applications. And finally, because we've sort of preordained what applications are running on each of these nodes, we can't rearrange them and say, well, turns out we've got two different kinds of services, and the workload is such that actually it makes sense maybe to combine them into a single node because neither of them is really busy enough, right? So again, what we really want to be able to do is sort of pick up our applications and move them and put them anywhere we want in the nodes and compose those applications into the nodes in an arbitrary way. So like I said, it can be, like I said, it would be really nice for, say, doing testing and development to be able to just combine all of those things into one node, right? So once it's in one node, you have just one shell where you can do the tracing of all the different functions that might be handling the requests that you're trying to understand, right? And then if it would be great if we can, more easily share, the applications around and recompose the nodes in order to sort of balance out be able to rebalance the workload between the nodes. So that was the motivation. So it turns out what we need to do isn't really that much, right? I mean, the system was designed to be able to have these composable applications. The whole idea was that in fact, the reason they're called applications, right, is so that you could load them and have them, load them and deploy them into Erlang nodes. So they are intended to be sort of these independent things that have these APIs that we talk to. But what's helpful is to basically follow good design practice, right? We want the OTP applications they should be single purpose. They should have very well-defined boundaries, right? So you don't want them sort of two applications kind of leaking information back and forth between themselves. The API should be fairly clear to what the entry and exit points are, and we should understand how the applications are dependent on one another, right? So that we know what that dependency tree is. Okay, any questions? No? All right. And then, so that's what we need to do sort of on the application side. Again, it's not a lot. But what the real challenge is to separate the OTP application from the release that's using it, right? We don't want to put the two things together in the same repository. And what that means is that we end up with a separate repository for each of our applications, and then we end up with a repository for what's essentially the node configuration, right? So we'll have a application, we'll have all the applications sitting in their own repositories so that they can be used as dependencies of other applications. And as we'll see, we can use that dependency mechanism to do the composition of the nodes. Okay. So in the application repository, what we do is we just don't do the release in there. And what we want to do is rely on the repository we create for the node to build the release. But we still list all of the dependencies of the application as we always would, right? So if an application depends on Mnesia or whatnot, then that's what we would, and that we would still do that. All right. Now for the interesting part is in the repository for the node. So here, what I did was I created essentially an empty application in that repository, and then built a release around it, right? So the application basically didn't do anything. But what it does do, what you do is you list as dependencies of that application all the applications you want to include in that node, that you want to sort of compose into that node, right? So that when you generate the release, when you grab the dependencies, you'll suck in all the code from the repositories that are those applications. You will build the release around them. The release handler will automatically start them all, right? So you don't have to do anything special. And then you're all set, right? So the only thing that you have to the only thing you might need to think about at that point is, are there any sort of configurations that are now specific to that node, right? That particular composition, right? Because maybe there is something special about it that it needs to be configured in a different way than if it was just running one thing. There is also possibly the idea of there being a master application on that node. And by that I mean not like a controller, but that there is a sort of an application that this sort of blank, this empty application might need to hold on to some of the private files that the other applications rely on. I had when we get to the examples, in one of the examples, we wanted to put the private files in some private files in the priv directory that was more closely associated with the release than with the application that they were actually coming from. And so we needed to be able to tell that build process where to put the priv files, the priv directory, where the application name of the sort of the top level application, the one that was connected to the release. Okay. So the structure then becomes a little bit different, where we have a Git repository that's holding on to essentially just the release, and that's what we use to generate the nodes. Then there are separate repositories for each of the applications that are then pulled in as dependencies of the release, and there are still dependent applications that are coming from elsewhere, right? That need to be incorporated, right? Does that make sense? Yeah. So this is great, except that. What about any of the applications that's providing a shared resource, right? So Mnesia is one example. Cowboy is another. So for example, with Mnesia, there's the challenge with Mnesia is the setting up the schema, right? So if you're starting up on a completely clean system, you need to create the schema, and you need to decide if that schema is going to be on disk or if it's going to be in memory. And you have to do that before Mnesia starts, right? Before the Mnesia application starts. Otherwise, you have to shut it down. If it started the wrong way, you need to shut it down. And if it just starts up with nothing there, right, you'll get an in-memory schema. And then, well, I guess you can just change the storage type, right, and then it becomes an on-disk one. But you still have to, there's still this startup issue. And there's, so it can be a challenge, a little bit of a challenge to share Mnesia across the different, if you have, say, you're composing together 3 applications that all want to use Mnesia, right? They all have to agree on how it's going to get started, right? And they have to agree on how to, say, create their tables. And then Cowboy, right, you need to add your routes and then also start the listener, right? So there has to be some agreement on who's going to do that, particularly if you're going to share the same port number, right? Because you can only have one listener for a particular port. So what do we do about that? And so what I did in the in our proof of concept was I essentially wrote a very thin, I made a repo that was a very thin manager around, say, Mnesia or Cowboy. And the OTP applications that wanted to use that resource, say, that wanted to use Mnesia, would include as a dependency the thin Mnesia manager. And the thin Mnesia manager would then say that Mnesia was its dependency. And that thin manager would have provided an API to create the tables and to decide what the schema type should be. So sort of the Mnesia startup then became part of this thin manager, and the applications that wanted to use it would just use that API in order to get started. But once it was started, that coordination was over, then they're basically independent of one another, and they can just use Mnesia normally, right? So it's just a matter of sort of that boot up phase, how to get started. So the thing that was interesting about this to me was that what it also meant was that sort of the configuration that went into that for that thin manager, as far as how to deal with the resource, actually now became a configuration for the, it was a configuration now for that release, for that, how we compose that node. So the decisions are now more about, once we decide to create a node, what are the, how is that thing supposed to be configured, rather than sort of each application making a decision about it. So there still needs to be some coordination there to make sure there aren't collisions on that. Okay. So I wanted to just show some what that looked like. It's going to be a little bit hard to type by looking over my shoulder. Okay, so I just called it, oops, where am I? Oh, there it is. Okay, so I just called it Erlang Mnesia. And so we can see in the rebar config that it doesn't say that it's dependent on anything, because it's not dependent on any other repositories. And in the source code, again, it's very thin, but the API is just here, where all it does is it has a function to create the tables. So so the API into it is to give it a list of table definitions, and then it creates the table. It creates the tables if they don't already exist, and then it waits for them to become available. And then, so if we were to look at that down here, just see what maybe exists, right? So it's pretty simple. All it does is it gets a list of all the tables, sees if it's there, and if it's not there, then it will create the table. If it is there, it just waits for it. Actually, there is no wait. Oh, the wait was another function call. Yeah. So, and that's sort of all that was really needed there to do the coordination. And then separately, there's single configuration that can be put in the sysconfig, which is whether or not the disk schema should be made persistent, right? And again, that ends up being a decision for the whole node, right? So all of the all the applications need to at least be aware that it could be one way or the other. Right, so one error that came up was that it was persistent was set to false, so it was keeping it in RAM, but one of the applications wanted to create an on-disk table, and so of course Mnesia complained about that, right? So I had to switch it, for that node, I had to switch it to being persistent, right? Okay. All right. Okay, so that was that. And then I wanted to show how it was used. And that's in, oh, I'm in the wrong window. Should be over here. Oops. In, yeah, Dobby core node. So in here, in Dobby core node, that's going to be using the, so this is now a node that was been composed. So if we look at the rebar config, it's using something called, it's using Mnesia, and then it's also using something called Dobby, which was originally called Dobby. It was renamed. It originally was called Dobby. Now it got renamed to Dobby Corelib, and I never changed it on the left side. So now we've composed a node together that just basically has these two pieces, and then we'll talk about the third one, the Erlang sshd, in a minute. And then that's it. The rest of this is all very, very thin, right? That there's basically the only thing in here is the .app file, right, which lists the applications that it's dependent on, right? And we rely on the fact that Dobby is going to say that it's dependent on the Mnesia, right, in order to build that dependency. Okay, oops. And then, so that was the node, and then the, probably did this in the wrong order. Dobby, oh, I didn't pull Dobby Corelib. Okay, so forgot to do that. Anyway, so in Dobby Corelib is the thing that is making the call to Mnesia. All right. Okay, so then the other thing was, there was this, the other one that was there was this Erlang sshd. So this one was a little bit different, and this was actually where the inspiration to think this through came from. We had the client I was working with, Infoblox, was working with their research group, doing some prototyping of things, and they said we built a bunch of different applications for them that were all running in these different nodes, and they said, can we get a SSH shell into the Erlang node to get the Erlang shell, the shell prompt, so that we don't have to have Erlang installed everywhere to make a remote shell connection. And it's like, okay, well doesn't seem like it'd be too hard. And it's all behind firewalls, so that management of usernames and passwords was not a big deal to them. They just wanted to be able to make that connection. And so we did that, and it wasn't that much work, but still it involved a few hours of coding and testing. And then they said, oh, that's great. Can you do it in this one too, right? And it's like, okay, let's not keep, because they're going to ask for it in all of them, right? So let's not keep doing the same work over and over again, although maybe it's good for consulting because you're paid by the day. But I said, let's think about a different way of doing this. And so what we came up with is this idea of, what if we could make a repository, right, that you could use it as a dependency, and all you need to do is include it as a dependency, and now you've got SSH access into your Erlang node, right? Could we make something self-contained like that? And so that's what this is. So if we sort of, as you noticed when we went in, where was it? In here, in the Dobby all-in-one, or here, even in the Dobby, we can look at Dobby all-in-one here. Obviously, I haven't done the compiles in these trees, but we've got in this one we have the Dobby, we have the URL sshd, which gives us the SSH access, and then this is also one that is basically an all-in-one thing. It's got all the components in it, so it also has the REST interface and something called the UI, which is a JavaScript interface. Is basically the UI thing is basically just a holder of the all the static JavaScript files, right? It just needs to be included so it can get copied into the priv directory. Anything? Oh yeah. So then we can also look at sshd itself. So here, there's a helper script that will generate the keys. And then in the source tree, it's actually relatively simple. The main part of it is right here, where it pulls out a bunch of the configuration information about what to do. And here's this business about the master app. So what we wanted to do was put the keys, the public-private keys, the encryption keys, in the priv directory of the application that was closely associated with the release. And so this needed to know what that application was, right? Because there's no way of knowing. And so it looks in we put an environment variable in that tells us the name of that'll give us the name of the master application. And then from there, we can pull out we can get the private directory of that application, and then we put the keys in this URL sshd directory. Right. So then all this does is it starts the daemon, and pretty much that's all this server does. The only other reason it would wake up is if the daemon crashed, which is fine. Let's see. I think that's all I wanted to show there. Okay, and there are like some other examples. I did a very thin wrapper around URL Cowboy. I'm sorry, around Cowboy for our REST interfaces, and then there's other ways in which things were composed. The all-in-one node, which you saw, and then there's this REST node that has, I think, just the REST component. The REST application, the REST API for Dobby in just that node, so that we can run if we want to, we can have sort of the Dobby, which is the database engine, running separately from its REST interface, right? We can run those on two separate nodes if we want to. Or we can run them all together if we're trying to do debugging. Okay. One of the challenges with this, though, is that now you've got sort of code scattered into different repos, right? So the repo that you were using to build the application or to build your node is no longer the repo that has the source code in it that is the application that is the primary purpose of that node, right? And so that can be a bit of a challenge. And then also because we had separate repos for all these different components. Sometimes we would discover a bug working on this one only to find out that the problem was actually in one of the dependencies, right? And so the really awful way of having to fix that was to do the fix here, test it, check it in, and then pull it, and then update the dependencies, and that just was really tedious. So what I ended up doing was just making symbolic links for the dependencies. So after doing a rebar get deps, I just remove the directory and made a symbolic link to where I had it. I had another clone, a clone of that tree, right? So that I could actually just do the work all together. But that's one of the challenges with this structure. And that's that. That's it. Are there any questions? No? Yes?
You mentioned that if you want to configure Cowboy for different applications, so basically there will be one Cowboy application with listening on one port, and you would just put like all the endpoints into that single port?
Yeah, so that was the idea, right? So if you were, I mean, what we wanted to do, right, was to have a single port that we would then have all of the, if we composed together a bunch of the REST APIs, we wanted a single port that they would all connect to. And so the way I structured the Erlang Cowboy is it handles launching Cowboy with the right port number. And then it turns out that Cowboy, you can dynamically add routes to it, right? So you can, even after it's running, you can add more routes. Yeah, so I was surprised too. So, because that's not typically the way you see it used. So it was fine to start it, and then when an application starts up later that says, oh, I'm a REST interface and I need to install routes, you can just, it still calls into, I think there's still an API in Erlang Cowboy just because it's the thing holding on to the kind of the reference to the server. But then all that does is it just adds the routes to that reference, right? Yeah, Stephen.
Since you have a few things here that are global that you needed to create wrappers for, and you can imagine in the future other dependencies might also require those global wrappers. And that seems a little bit inconvenient or undesirable. If you could wave a wand and make the world be designed the way that would really fit this model, have you thought about what it would be and how these things could be changed?
Yeah, so the question is that it seems inconvenient to have to write these wrappers around these applications that basically aren't playing nicely. It's like, what is there, how would I like to see these applications designed to make this basically more natural, right? Is that fair? Yeah. I think I've thought a little bit more about Mnesia than I have the others. And I think that with Mnesia, it would be nice if right, so let's back up one step, right? These wrappers are only needed because they're not playing nicely with this way of composing the application, right? They're a shared resource, but they don't really have APIs that are amenable to that kind of sharing, right? So for Mnesia, for example, it would be nice if there was a way of providing environment variables or something for its startup that could be used when it starts up to set sort of these options ahead of time. And then also maybe an API where you can do, as I did, which is like maybe create the table, right? Create or wait for table, right? And so it could then start up the, you would have a natural way of having it start the Mnesia for that node, and then you'd have an API where you can just say, well, here's my table definitions. Just tell me when they're ready, right? Or give me an error if there's some conflict. Yeah, I think that would be good. Yes, in back.
But even in that case, if you had consistent state and you decided to split the node, you have to have some kind of migration strategy to remove the tables of all the things that you split across.
Yeah, that's correct, right. So if in that case, if you decide to split your node up, you would have to have some strategy for moving the data because you've now split the data from into two different nodes. And yes, that's absolutely right. But that was beyond the scope of sort of this discussion, just sort of thinking about this. Yes?
So two-part question. First is, you mentioned you were doing this as part of some work you're doing for InfoBlocks because you have a particular need.
Right.
Could you say a little bit more on how it all, did it get distributed the way you wanted? Did it all work? And the second is that code available? The stuff you're just showing us, is that code available?
Sure. So the first question is, did it we were doing this for info blocks and did it really fit the need? And I think the answer is yes, because what the need was, we wanted a way of, what I should say is that the project that we were working on was all very, very proof of concept. And we weren't sure as we were designing it what the right choices were. And so this gave us more flexibility to experiment, right? And so from that point of view, I think it was successful. I think also from the point of view of productivity, because we were building a distributed system, and being able to do the testing and debugging with it all in one place, one node, even though eventually it was expected to be split up, really saved a lot of time. It really made it much, much easier to do the debugging. The second question is it available? Yes, it's all in open source. It's all public open source. Yeah. All right. Any more questions?
I have one myself.
Oh, yeah.
Have you any thoughts about tooling for version control of this? So if you use the same library, for example, in two projects, and you have version 1 that you need for this first project,
Yeah.
and version 2 for another one, and so on, and all your different libraries that you have, your components for your node,
Right.
and keeping track of which version and making releases for those versions for a specific node.
Yeah, so the question is about sort of version management, software version management. I haven't, but basically I think Rebar does that for you, right? So when you make a dependency, you can say which version of the repo that you want for it to release.
So I was thinking of tool of saying, okay, now I have these branches that I want to turn into a release for this system.
I have these, I'm
So
sorry, I'm
we
not
have
following.
We have to go into your rebar config and set the versioning on them for you had your bug fix as an example, where
Yeah.
you had to fix some things in one repo and
Oh.
some things in another repo.
Yeah,
And then when you want to do release, you want to do this at the same time in some way. So
Yeah.
you want to automate that in some way.
I see, right, so automate sort of this management of the versions. Yeah, no, I haven't given that much thought. Yeah, I think the level of complexity that we were working with wasn't high enough to need a tool to think it through, if that makes sense. I think for us, it was still relatively simple. And then it wasn't production code, so we weren't really doing releases anyway, right? And that's probably the better answer, which is we hadn't gotten that far in sort of how to do the deployments. Yeah, right.
The Git standard way would be to use tags, right? Use
Yes.
Tag the release
Yeah.
at a certain point.
Then you have to put the tags back in the rebar config.
Yeah, it'd be nice if there was some tool that would you could use to say both tag it and update my dependency, what's in my dependencies, maybe, right? So basically, tag the repo and also update my rebar config.
Gotcha.
Yeah, that's an interesting idea.
Necessarily in the top level, like in the release application, when you try to fetch dependencies, it would probably crash and say mismatch between dependencies, right?
If what? I'm sorry?
If you have, let's say you have application A that uses a dependency,
Yeah,
and another application that uses the same dependency but a different
version, right.
Once you try to build like the release application, it would crash saying.
Right. Yeah, right. If there's a version clash that's detected by rebar, yeah. Yeah, I was going to say Git, but I meant rebar. Yeah.
Okay.
All right. Any more questions? Great, thank you.